Hi, it's Ross and Mia's Chapter 6 review! Yay! Aren't you guys excited? First, we're going to start off with finding the sum of the measures of a convex polygon. Remember that this formula I'm going to show you is only for convex polygons, like the ones with symbols in the center. Concave ones look like the ones without the symbol. The sum of the measures of the exterior angles of any polygon are always 360 degrees. The magical formula for finding the sum of the interior angles of a convex polygon is 180 times n minus 2. N is the number of sides. Why don't we find the sum of the interior angles of the pentagon below? So that is 5 minus 2. So that's 3 times 180. And that is 540. Woohoo! Good job! You can multiply and subtract. You're like so multi-talented. Okay, moving on. Do you remember what I said about the sum of the measures of exterior angles of any polygon? What is a stupefying number? Is it 180? No. Is it 540? No again. Is it 360? Yes, you're right. Oh my gula, you have a good memory too. Now to your question. What is the sum of the dodecagon below? What can it be? What can it be? It's 360 again! Dang, you are so smart. Yay, a sample problem. First, let's start out with finding out the sum of the interior angles of this heptagon. So that is 7 minus 2, which is 5, times 180. That makes 900. Okay, so next let's add up all the interior angles and set it equal to 900. So x plus 20 plus x minus 10 plus x plus 2x plus x plus 25 plus x equals 900. Ew, it's a mess of x. Okay, let's clean this up a bit and add up all the same variables together. So that's 8x plus 35 equals 900. Next up is all the fun, easy stuff. So now we subtract 35 from 900, which is 865, and divide that by 8. Now that is 108.25. This is actually the correct answer. Don't worry though, most of the problems you have to solve equals a whole number. Next up, we're learning parallelograms, their properties, how to find some angles of parallelograms, and how to test for parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. That is the definition. Some sample parallelograms are the ones shown. What I just told you is the definition, or the defining characteristic of a parallelogram. Of course, there are other parts of the parallelogram besides that. These are called properties. In a parallelogram, its opposite sides are congruent. The opposite angles are congruent. Its consecutive sides are congruent. If one angle is 90 degrees, they all are. Its diagonals bisect each other. And that the diagonals separate the parallelograms. If you don't know what shape a polygon is, and they have one of these properties, then you know it's a parallelogram. Aren't they neat? Example time! Ugh. This has two variables. How utterly daunting. Not. Anyways, time to use those parallelogram properties we were just talking about. Which one could be useful here? Aha! In a parallelogram, its opposite angles are congruent. That's totally useful. Now we know that y is 101 degrees. Now I subtract 101 from 180 because the consecutive angles of parallelograms add up to 180. And x equals 79! Yeah, we did it! Woohoo! Testing for parallelograms uses the previous properties and actually applies them to quadrilaterals, so we can figure out if they are parallelograms. Let's get started. If you're trying to find out if a quadrilateral is a parallelogram, and you say yes to any of the below, you have a parallelogram. Congratulations, it's adorable. So you have a parallelogram if both pairs of opposite sides in a quad are congruent, or if both pairs of opposite angles in a quad are congruent, or if the diagonals bisect, or if one pair of opposite sides of a parallelogram are parallel and congruent. Good for you for paying attention this far. Keep up the hard work. Example, why don't we go through our test to see if this figure is a parallelogram? Let's go through the first one. Are the pairs of opposite sides in this quad congruent? Yes! Why yes, this is true! Well, wasn't that one easy? I'm truly sorry, but we're done with parallelograms for now. Boo-hoo, I know how you're sobbing in the inside. On the bright side, now you're learning about rectangles. These little figures are parallelograms with 4 right angles. Hey, the parallelograms aren't really gone. Properties of rectangles, let's go. Remember the definition of a rectangle, and that all, as in every angle, is 90 degrees. Since rectangles are parallelograms, by definition, their opposite sides are parallel and congruent. their opposite angles are congruent, their consecutive angles are supplementary, and their diagonals bisect each other. In addition, if a parallelogram is a rectangle, their diagonals are congruent. You can switch my words around to say the next thing. Yay, problems! Okay, so let's go through our list of properties to see if this is a rectangle. Are all angles 90 degrees? Why, yes. One angle's right, so all the other angles are right as well. On top of that, you can see that the opposite sides are parallel and congruent. The opposite angles are definitely congruent, and that the consecutive angles are supplementary. Good job, you're good at this. We're just ripping through this material. Next up, we're learning about rhombi and squares. A rhombus is a parallelogram with all four sides congruent. A square, on the other hand, is a parallelogram that is both a rectangle and a rhombus. Next, we're going to learn about their properties. It's time to find the properties of a rhombus and a square. Don't worry, even though these are two shapes, it won't take that long. Let's start off with a rhombus. A rhombus is a parallelogram with all four sides congruent, as I said earlier. Remember this because it's the definition. A rhombus is also a parallelogram with the diagonals perpendicular, and when each diagonal bisects a pair of opposite angles. In addition, if a pair of consecutive sides of a parallelogram are congruent, it's a rhombus again. All you need to remember for squares is that if a quadrilateral is both a rectangle and a rhombus, it's a square. That means that a square has all the properties of a rectangle plus a rhombus. Don't forget this. Here we go again. So this time we're trying to find the x in this rhombus. Try to remember that special thing about the diagonals of a rhombus. Oh yes, they're perpendicular. We'll set the value of 2x plus 52 equal to 90. And now we solve. So that's 90 minus 52, 38, divided by 2. That's 19. Great job. Sample time. Remember how a square is a rectangle and a rhombus? That means we have to find both in this figure. Why don't we see if this is a rhombus since that's still fresh in our mind? So a parallelogram is a rhombus if all four sides are congruent. Hey! All the sides are congruent here. In addition, you can see that the diagonals are perpendicular, a sign of a rhombus. Okay, so now let's see if this is a rectangle as well. If a parallelogram is a rectangle, then its diagonals are congruent. Well, here it is again! On top of that, the opposite sides are parallel and congruent. This is totally a square because it's a rectangle and a rhombus. Neat! Last, but certainly not least, we have trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. These parallel sides are called bases. The non-parallel sides are called legs. If the two legs of a trapezoid are congruent, then they are an isosceles trapezoid. A kite, on the other hand, is a quad with exactly two pairs of consecutive congruent sides. You guessed it, it's the last set of properties for this entire video. Can you believe it's almost over? Anywho, let's start off with the definitions of a trapezoid and an isosceles trapezoid. Remember that trapezoids are quads with a pair of parallel sides called bases, that the non-parallel sides are called legs, and that a trapezoid is an isosceles trapezoid if the legs are congruent. In addition, the place where the base and legs intersect are called the base angles. In an isosceles trapezoid, the base angles are congruent. The converse of that statement is another property. On top of this, an isosceles trapezoid has congruent diagonals, and the midsegment of a trapezoid is halfway between the two bases and parallel to the bases. If you recall, a kite is a quad with two pairs of congruent consecutive sides with perpendicular diagonals. Oh, look at this intimidating problem. Now you have to find the base, not the midsegment. We're going to have to plug some figures in order to find the top base. So first, let's go over the formula to find the midsegment. So that would be x plus 18 divided by 2 equals 15. That's great, now we solve. 15 times 2 is 30, and 30 minus 18 is 12. X is 12. Nice work. Ew, this one looks scary too, but don't worry, I bet you can work this one out just as well. So first, let's generate a formula. Remember that the interior angles of a quad always equal 360 degrees, and that the two angles not noted in this kite are congruent to each other. So our proper formula should be 2x plus 70 plus 56 equals 360. Now we add up like variables, so 70 plus 56 is 126. So let's put all like variables on the same side. So 2x equals 234, and we divide 234 by 2, and that's 117. Great job on our last sample problem. That's it for Chapter 6. Thanks for listening.